So functions and relations we've talked about a lot before. Reminder, a relation is a pairing of input values with output values, like an ordered pair or a set of ordered pairs. So notation-wise, if you have a set of ordered pairs, individually you put the squiggly braces around your set that consists of your relation. Your domain of your relation is all of your input values. So like on this relation I just made up, your x values are 1, 2, and 3. Those would be in your domain. And your range is the set of all, gotta change my notes here, output values, which for this one would be 2, 4, and 5. You don't have to repeat 5 twice. Now this one is not a function because it has an input value of 1 that maps to both 2 and 4. So we're like, well, if I start at 1, where am I supposed to go? I could make it a function by just removing that ordered pair that repeats my same x value. So that's a quick little refresher of relations and functions. One kind of handy check to see if the graph indicates a relation as a function is by using the vertical line test. So like an absolute value graph would be a graph of a function because no vertical line would pass through it more than once. But if I had this little sketch that looks kind of like a sideways parabola, a vertical line would intersect it twice, which means you have points that share the same x coordinate. So those would not be functions. Let's take a look at a few here. So I can tell this first one's not a function because if I was to draw a vertical line through it, it would hit it multiple times. Thinking about domain and range, domain is my x values stretching like across horizontally. So this is a connected line, so it hits all x values between the furthest to the left point and the furthest to the right point. So it looks like about that x value on the left is 1.5 maybe, over to the x value of about 6.4. I'm approximating it a little bit here. My range vertically between my largest and smallest y values looks like my smallest one's about -2, I'm pretty sure that one's exactly -2, up to 4. I'm using square brackets because those are included points. If you look at this individual ordered pairs over here on part B, I would go ahead and label them first. And then it is a function because you don't have any of them that share the same x value. Your domain, we're going to have to use the squiggly braces for my set because those are individual disconnected ordered pairs. And I've got my range is my y values right there. If I am evaluating a function, I'm essentially just replacing my variable with my input value. So I'm going to take this function and replace x with -2 and see what output I get. So make sure you follow order of operations and put things in parentheses when you substitute them in. So when I plug in -2 and square it, I get 4. 5 times -2 is -10. And then if I have -4, -10, and -3 all together is -17. The fact that I'm plugging in a plus 2 doesn't really change how this works. I'm going to replace all of my x's with the quantity a plus 2. So just rewriting it with a plus 2 in place of x. And then it's a little bit more work to simplify because I'm going to have to square my a plus 2 by taking it times itself. I'll go ahead and multiply 5 times a plus 2 and get 5a plus 10. So I do still have that negative out in front, so I'm going to take a plus 2 times itself. And then I'll have to change all of my signs on it because I have -1 being multiplied times it. I'm just going to erase and rewrite my signs. Now some like terms can be combined here. So if I put my like terms together, I'm going to have a -a squared plus a, and then plus 3. So let's evaluate some functions that you don't have an equation for. So I'm essentially just looking for what I get when I plug in 0, if I'm talking about g of 0. My input value is 0, what's my output value? We'll go over to my relation and go, oh, my input value of 0 is supposed to send me an output value of 2, so g of 0 is just 2. You can also evaluate one looking at a graph. So if this is f of x and I want to figure out what f of 2 is, this says when x is equal to 2, what output value for y do I get? So go on your x-axis and find a point that has an x value of 2 and look at your output value. If you go to 2, you get an output value of 3, so f of 2 just equals 3. How about you find f of negative 1? Okay, so a of s equals s squared is giving us the area of a square with the side length of s. So if I'm finding a of 2, I'm just plugging 2 in for s and getting 4. And what exactly did I do when I found a of 2? Well, that told me that my input, my variable's value for s, was 2. S stood for the side length of my square. So I got the area of my square when I had side lengths of 2.